For everything that I just showed you on the previous slide to work, we have to have fault-tolerant message processing. So now I'm going to go through exactly how that works. What I show on this slide here are 3 clients, and these clients are posting messages into a queue, which is this rounded rectangle in the middle. Right now they've posted message 1, message 2, and message 3. Now each of these messages has a subscript 0 next to it. That is called the DQ count. It's an integer, and it indicates how many times this message has been DQ'd from the queue. Initially, the DQ count is set to 0 for any new message that is placed into the queue. I also show on this slide 2 service instances, right? So this is service instance 1 and service instance 2. These 2 instances are going to be trying to pull messages from the queue in order to process them. So let's go through this process. When those 2 services, they try to get a message from the queue itself is going to increment the DQ count. So message number 1 is going to be the first message to be DQ'd, and the DQ count is going to be incremented from 0 to 1. And then what the queue does is, rather than remove the message from the queue simply hides the message from the queue. We call it invisibility. The queue makes the message invisible for some period of time, usually expressed in seconds, like maybe 5 seconds or 10 seconds. Whatever amount of time you think it's going to be required in order to process the message from the queue. So if you think processing the message is going to take 10 seconds, then you would typically make the message invisible for 10 seconds. So let's say service 1 goes and tries to get the message from the queue. So the DQ count gets incremented from 0 to 1, and then the message becomes invisible. You can see, hopefully you can see, that I've shaded it a little bit. It's not the deep black, right? It's more of a grayish color to say the message is still there, but it's invisible. Then the message was given to service 1, and now it says, okay, I'm processing this message, and it's been DQ'd 1 time. Now, when a service extracts a message, the first thing that service should do is it should look at the DQ count, in this case, which is 1. And if the DQ count is greater than some threshold, now in my example on the slides, I'm going to demonstrate this using a threshold of 2. But in real life, we tend to use a bigger threshold, but not much bigger. You might use a threshold of possibly 4 or 5. It's unlikely you would choose a threshold of 10 or 20 or 100. And I'll explain what the threshold is for very shortly. But basically, well, I'll explain it now. So basically, if the message is DQ'd higher than some number, that means that the message keeps failing to be fully processed. Right, and so it keeps getting processed repeatedly. That probably means that it's a poisoned message. So what the service would do is, if the DQ count is greater than some threshold, the service would log the bad message into like a poison letter queue. And then it would simply delete the message without trying to process it at all. Because processing it is probably going to cause the service to crash. That's why the DQ count is so high. The message keeps getting reprocessed because it never gets fully processed. And I will explain this more as I go through the animated slides. Else, if the DQ count has not reached the threshold, then the service begins processing the message, and when it completes processing the message, it will delete the message from the queue. All right, so let's see how this plays out. Service 1 has pulled message 1 from the queue, and the DQ count is 1. The DQ count of 1 means it's lower than our threshold of 2, which is what I'm using in this example. So service 1 starts processing that message. If service 2 tries to get a message from the queue will say, well, you can't have message 1 because it's invisible, so I will give you message 2 instead. The queue increments the DQ count to 1, and now service 2 is processing message 2, and it has a DQ count of 1. Since the DQ count of 1 is less than the threshold, the service does process the message. Now let's say service 2, it finishes processing the message in its entirety. So then it goes and back to the queue and says to the queue, I have finished processing message 2, delete it. And so the queue now actually removes the message from the queue. It's no longer invisible. It has now been fully deleted from the queue. It does not exist anymore. So no other service will ever see message 2 ever again now. Now service 2 would go and pull another message, and it might go and get message number 3. But let's postpone that for a moment, and let's turn our attention back to service number 1. Service number 1 is still processing message number 1. And in the middle of the processing, a crash occurs, and that service instance gets on fire, and it goes down. So now service 1 is dead and no longer running. Now, the orchestrator that we're using should restart service 1 and crank it back up. Meanwhile, however, this message, the number of seconds that it was invisible before, that expires, and so the message becomes visible again. So now we have message 1 in here, and it's going to be dequeued a second time, and therefore the dequeue count got incremented to 2. So this time, it's now being given to service instance 2 because it was visible. So now service instance 2 goes and gets message 1, and the dequeue count is 2. That's still less than the threshold, and so service 2 begins processing that message. But it's probably going to crash that service as well, and so now service 2 is now down. Meanwhile, service 1 has come back up because our orchestrator has brought it back alive. The message number 1 has become visible yet again, and now its dequeue count is being set to 3 because it's about to be dequeued for the third time. So now service number 1 says, well, let me go get a message from the queue, and it goes and gets message number 1 again, but the dequeue count is 3. But as you can see, what happens here is that if the same message is being replayed over and over again, it's very likely there's something wrong with this message. There's either a bug in the message itself, or there's a bug in the code that processes the message, but this message is causing these server instances to crash repeatedly. We don't want to just keep doing that forever, of course. And so that's why we have this dequeue count integer. And the services, when they pull a message, they look at that dequeue count to see if it's greater than some threshold. In my case, I'm using 2 as the threshold. Now this dequeue count is 3, which is greater than 2. And therefore, service 1 is going to say, all right, this is the third time we're attempting to process this message. That means we've been unsuccessful 2 times prior. So I'm not even going to try to process it. I'm just going to log this message somewhere else so a developer can go and look at the message, replay it at their developer machine, and try to find the bug. It's either in the code that produces the message, or it's in the bug that processes the message to figure out what's wrong. And then service 1, after logging this so a developer can look at it later, it's just going to delete the message from the queue and from the service itself. This prevents the message from being repeatedly played back anymore, causing more service instances to crash. At this point, of course, service instance 2 would rehydrate itself, right? The orchestrator would bring it back to life. It would try to get a message from the queue, and now it would start processing message 3. Or service 1 could now start processing message 3, right? Whichever one goes to the queue next will go and get the next message. So this is how we're getting this fault tolerance of message processing. Again, this is really like retries, right? We're pulling a message from the queue. We failed to process it, so we're going to pull it again from the queue, and we're going to retry it. But we need to make sure that the processing of that message is done idempotently in order to make this work. So I have a note here on the slide that because of this behavior, messages can be processed more than one time. I just showed that service 1 got message 1, service 2 got message 1, then service 1 got message 1 again, right? So it tried to be processed multiple times. I also showed how these messages can be processed out of order. Message number 2 was fully processed, and then we started processing message 1 again. Right? So you need to make sure that your code has no expectations on the ordering of these messages, and that you are idempotent for messages being retried. And this is how queues work in this environment to give us this fault-tolerant message processing.